Okay, last video we have here is going to be dealing with dividing complex numbers. The big thing that you guys need to remember with dividing complex numbers is that I equals the square root of -1. So much like we cannot have square roots on the bottoms of fractions, we also cannot have i's on the bottom of fractions. So these things are going to work the exact same way that we did when rationalizing the other denominator. So here, if I have a 2 over 9i and it is a single term, so if it's a single term, I can just multiply by an I to get rid of that I. If it's our two terms, that's where we have to do the radical conjugate. Okay, so starting out with, we've got 2 over 9i. I need to get rid of that I on the bottom. And the way that I do that is to multiply by I, because I squared equals -1. And whatever I do to the bottom, I have to do to the top as well. So on top, I have simply a 2i. And then on the bottom, I have a 9i squared. I times I gives me I squared. So this is where it comes in. We remember I squared equals -1. So this is a 2i over 9 times -1, because I squared equals -1, which gives me a 2i over a -9, which the better way to write that would be a -2i9. Okay, so it really doesn't matter. Say I have 3 over I. I'm going to multiply by I over I. Okay, gives me a 3i over an I squared. That's a 3i over a -1, which would just be a -3i. Technically, that's a 3 over 1, but anything over 1 is just itself. So 3 divided by I would just be a -3i. So if there is just an I on the bottom and it's a single term, all you have to do is just multiply by whatever, or just multiply by I. Okay. Then the other example, say we have a binomial on the bottom. Okay, this is where we do have to multiply by the radical conjugate, which, remember, for the conjugate, you just change the sign in the middle. So that's a 3 plus 2i, 3 plus 2i on top. Okay, so I get a 15 plus 10i over, on the bottom I'm going to have to FOIL, 3 times 3 is 9. 3 times a positive 2i gives me a positive 6i. Negative 2i times 3 gives me a negative 6i. Negative 2i times a positive 2i gives me a -4i squared. Okay, remember our goal was to get rid of the i's. So when we multiply by the conjugate, those two i's there in the middle cancel each other out. And I'm left with a 15 plus 10i over a 9 minus 4. And then instead of an I squared, that becomes a -1. So that would be 15 plus 10i over -4 and -1. It gives me a positive 4. So 9 plus 4 gives me 13. The last thing you have to remember with this is that is not your final answer. Remember, all of our imaginary numbers have to be in the a plus bi form. So this would be a 15 over 13 plus a 10 over 13i. Okay, that 13 goes over both of them. So I guess just to kind of explain how I did that last one there, it's technically a 10i over 13. So 15 over 13, 10i over 13. And we just go ahead and separate that so that the b is 10/13ths and then the I is just on the back end of it. Okay, and that is how you go about rationalizing your denominators, and it's also how you go about dividing your imaginary numbers.